Hi there, my name is Haralabidis, and this is another video which is part of my video series which are focused entirely on the AP Precalculus syllabus. This time, we will see how to algebraically solve inequalities. This is part of Unit 1 in which we need to know also by hand, also algebraically, not just by graphically, how to solve properly an inequality. We'll begin by understanding what the table of signs of one linear factor is, assuming that we have this linear factor x minus 5. Now, we need to find the table of signs. The table of signs is a table that shows the sign of x minus 5 shows the sign, not the value, the sign, whether it's positive or negative. The sign of x minus 5 for all possible values of x. For instance, if x is 10, then x minus 5 would have been 10 minus 5 equals 5, therefore positive. If x is negative 20, x minus 5 would have been negative 20 minus 5, which is negative 25, and therefore negative. So we will do that for all possible values of x. And we will gather all this information on one table. How is this table being formatted? First of all, it should be a table, so it should look like that. On this section, I'm going to put my expression, x minus 5. The first step would be to find the 0 of x minus 5. This means find the value of x for which the x minus 5 is equal to 0. So x minus 5 equals 0. This means that x equals 5. And that 0 will be placed up here, where this is supposed to be a number line, starting from minus infinity up to plus infinity. So we have the 0 here. From that 0, I will draw downwards a vertical line. And at the level of x minus 5, I will put a 0 simply to signify, simply to notate that 5 is 0 of this expression of x minus 5. Now, there are two different columns which are being formed. The one at the left and the one at the right. Here, there is this tip. Since I am working with linear factors of the form ax plus b, remember that whatever the sign of a is, whatever the sign of a is, the same will the sign be at the right of this column. So in this case, the sign, we have a, it's not there, but it's assumed to be 1. So 1 is greater than 0, therefore it's positive. That same sign will be at the right of this. So here positive, and the opposite will be at the left of this. So at the left of that, we would have a negative 5. Once again, we begin by finding the 0. We create the table. We put that 0 on that number line, and then we look at the coefficient of x. If it's positive, then at the right of that vertical line, we will have a positive sign. If it's negative, then at the right of that vertical line, we will have a negative sign as well. Let's do another quick example, and then we'll see what happens when we have two linear factors. For now, let's focus on that table of signs, and let's assume that here we would get negative 3x plus 12. At first, I need to find the zeros of that. Negative 3x is negative 12, so by dividing both sides by negative 3, I would get that x is 4. So 4 should be put up here. Then we draw a vertical line like this, and we look at the coefficient of x, and more particularly at its sign. It's negative, which means that whatever that sign is, the same will be the sign at the right of that vertical line. So negative here, and the opposite at the left, plus a negative. Let's upgrade this concept by creating table of signs for two different linear factors. So, assuming that we have that table already, here we get 2x minus 4. Let's say here we get 3x plus 6. Again, in step 1, I need to find the zeros of each one of those separately. 2x minus 4 is 0, means that 2x is 4, which means that x equals 2. 3x plus 6 is 0, so 3x is negative 6, which means that x equals negative 2. So there I am. I have two zeros, 2 and negative 2. I should place them here on the number line, but be careful, they should be put in numerical order, from the smallest to the biggest. So at first we get the negative 2, and then the 2. From each one of these, I draw vertical lines, and I should put properly that 0 notation. 2x minus 4 gets to be 0 when x is 2. So each 0 should be put on that level. 3x plus 6 gets to be 0 when x is negative 2. So its 0 should be put on that level. Now, I will act as if I had each one of them in a separate way. 2x minus 4, the coefficient of x, here, number 2, is positive, which means that at the right of each 0, it will also be positive, and at the left, it will be negative. 3x plus 6, the coefficient of x is positive. So yet again, at the right of each 0, it will also be positive, and at the left, negative. In these cases, what we actually want to achieve is the sign of the entire product. So, assuming that here we get 2x minus 4 and 3x plus 6, so far we have managed to find the sign of each one of these factors separately. But now we want to find the sign of the entire expression, which is the product of these two. So we will basically go and say, from minus infinity up to negative 2, both of them are negatives. But we care for their products. Negative times negative, it should be positive. Between negative 2 and 2, one of them is negative, the other is positive. But the product, negative times positive, should be negative. From values from 2 and above, both of them are positives. So, positive times positive, the result should be positive. Let's do another example. I'm going to put here the x minus 5. Let's put the minus x minus 5. And the 4x plus, let's do plus 24. Again, I need the zeros. Minus x minus 5 equals 0. So negative x is 5. So x is negative 5. That's 1, 0. 4x plus 24 is 0. 4x equals negative 24. X equals negative 6. And that's the second zero. So we have the zeros of negative 6 and negative 5. And now I should properly put them in numerical order. Negative 6 and negative 5. From each one of those, I will draw two vertical lines. And on them, at the proper level, I will put the zero notation. Negative x minus 5 gets to be equal to 0 when x is negative 5. So I should put it at that level. 4x plus 24 gets to be equal to 0 when x is negative 6. So I should put it at that level. Minus x minus 5. The coefficient of x is negative 1. And that is a negative sign. And based on the previous statement, the previous hint I gave you, whatever the coefficient of x is, the same will be at the right of that zero sign. So negative here and the opposite at the left, positive and positive. The coefficient of x at the second one is number 4. It's a positive. So whatever that coefficient sign is, the same will be at the right of that zero notation, plus, and the opposite at the left, minus. Remember what we said earlier. It's most likely, it's a certain thing basically, that we will just care about the entire product. So from negative infinity up to negative 6, one of them is positive, the other is negative. When we multiply positive and negative, we end up with negative. Between negative 6 and negative 5, both of them are positives. So when we multiply two positives, it's positive. From negative 5 to plus infinity, one of them is again negative, the other is positive. When we multiply two different sign quantities, we end up with negative. And that's the table of signs. Now, what have we achieved with that? We can know for any possible x value, the sign, we will never know the exact value, but we care about the sign. We will definitely know the sign of that. Assuming that someone says, okay, so what would that sign be for x equals negative 3? Well, negative 3 is somewhere here. So for x equals negative 3, we expect to have a negative sign. What would be for x equals negative 20? Negative 20 could be somewhere there. We expect to have a negative sign as well. What could it be for negative 5.3? Negative 5.3 could be here. We expect to have a positive sign, and so on. Let's extend this concept for even more than two linear factors. Again, however, the process remains the same. Regardless of how many we have, it remains the same. So 3x minus 15, x minus 1, 4 minus x, and let's put here x squared. So, sorry, these are not linear factors. However, it could expand, let's put just x. However, it could expand in more than two linear factors. We need the zeros. And then down there, I'm going to put entire product, all of those. Let's begin by finding the zeros. 3x minus 15 is 0, so 3x is 15, x is 5, one of the zeros. X minus 1 is 0, so x is 1. 4 minus x is 0, so x is 4. And finally, x is 0 is that 0 itself. We should put them now properly in numerical order. We begin with 0, 1, 4, and 5. We don't necessarily need to put or to keep any scale. Just put these numbers. From each one of those, I will draw a vertical line like that. 3x minus 15. It gets to be 0 at 5, so the 0 notation should be put down there. Let me quickly fill in the table already. The coefficient of x is 3. 3 is positive, so this means that at the right of its zero notation, it should be positive and negative at the left. X minus 1. The coefficient of x here, it's not shown, but it is assumed to be equal to 1, which is positive. X minus 1 gets to be 0 here, so I'm going to put the zero notation here. And at the right of that zero notation, I should put the same sign, therefore positives, while at the left I should put the opposites, negatives. 4 minus x, the coefficient of x here is negative 1. It is negative. 4 minus x gets to be 0 when x is 4. At the right, it should still be negative, and at the left, positive. X, the coefficient of x is assumed to be 1. It's positive. X gets to be 0 at 0. So at the right of that, positive, 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 and at the left, negative. Now, we need to find the entire product. Look, one way would be to consider that from minus infinity up to 0, 3x minus 15 will be negative. X minus 1 would be negative. 4 minus x would be positive. X would be negative. So negative times negative, positive, then multiplied by positive again, positive, then multiplied by negative again, negative. This is, if you allow me, boring. We cannot go like this. We will most likely lose it at some point. Instead, I offer you a better way. Just count the amount of negative signs. Let me write that hint somewhere here. Count the amount of negative signs. If it's even, the final product will be positive. If it's odd, then the final product will be negative. So let's see in the first column, 1, 2, 3 negatives, we end up with minus. In the second column, 1 and 2, even amount of negatives, so positive. 1, it's negative. 1 and 2, positive. 1, negative again. And there you are. You have the sign of this entire expression. And that would be all. In the following next 2 videos, we will work more exercises, but for now, I hope that this video really helped you in understanding how to build a proper table of signs for a linear expression. If you thought the same, don't forget to like and subscribe. As always, thank you for watching and thank you for your time.